Hydrogen is the most common element on the periodic table, and it makes up over 75% of the elements in the universe. It's also the primary ingredient in H2O, or water, the most common molecule in the universe. It's the lightest and most simple of the elements, consisting of just one proton and one electron, although sometimes it likes to pair up with a neutron or two and make some exotic compounds like heavy water. Hydrogen weighs roughly at 1 atomic unit and has an average boiling point of only negative 259 degrees Celsius or 14 Kelvin. While you typically find it paired up, it also comes in the form of ions, which are just a single proton fired from coronal mass ejections on the sun, or as a byproduct of acid, not that kind of acid, base reactions. It's also highly flammable and responsible for one of the deadliest airship disasters in all of history. While hydrogen has caused a lot of terrible disasters, its power is often used in rocket fuel, as it combusts very quickly and efficiently while weighing much less than oil. Due to its clean and efficient reaction with oxygen, it can also be utilized for energy capture, making it a much safer alternative to car batteries. Helium is the lightest and most common noble gas on the periodic table, which is a group on the far end that are the characteristically gaseous, light-emitting introverts of the elements. Helium consists of 2 electrons, filling up its first shell, making it unavailable for bonding, a feature of all noble gases. Helium comes in 2 different forms: Helium-3, which is a tritium decay product produced through nuclear fusion and a theoretical sci-fi fuel source due to its release of energy when combined with deuterium, and Helium-4, which is much more abundant and can be produced in a variety of ways, including a different kind of nuclear fusion or as a byproduct of alpha decay. Helium is colorless, odorless, and non-toxic. Its only interesting physical property is that it doesn't have any. However, it has many uses, including, well, but other than that, it's also used in MRI machines, which need ridiculously cold temperatures for their superconducting magnets, and helium comes in handy due to its icy cold boiling point at 4.25 Kelvin. Deep-sea divers also use it to breathe easier under pressure due to its low density and not being, extremely flammable like hydrogen, which means, yes, professional divers sound like this. Lithium is the third element on the periodic table and consists of 3 electrons, leaving only 1 in the second shell, making it very reactive and able to form ionic bonds with its halogen buddies like fluorine. It's by far the lightest metal, weighing it at only 0.5 grams per cubic centimeter. For reference, the next lightest metal, beryllium, weighs over 3 times as much at 1.85 grams per cubic centimeter. Due to its weight, it's often used in rechargeable lithium-ion batteries because of their need to be lightweight and pocketable, including the one in your smartphone. However, environmental and health safety concerns due to its not-so-ethical mining process and, well, yeah, that's in your pocket right now. It's led to talks of replacing lithium batteries with less terrible ones, but other than the Method Man album, it's got tons of other uses too, like grease. Beryllium is the 4th element on the periodic table, aka the first one that starts with a B nobody can ever remember. It's a silvery lightweight metal with a high melting point of over 1200 degrees Celsius, and it's basically a stronger, lighter, much more expensive, and very toxic aluminum that also apparently tastes very sweet, so much so that it used to literally be called glucinium. It's used in aerospace and military applications due to its strength and lightweight, as well as being a key component in the James Webb Space Telescope because of its high melting point. It's also very useful for X-rays because of its transparency to the frequency, although in most applications it's much less commonly used than aluminum because it costs a whopping $6,000 per kilogram compared to like $3. In fact, it's so costly to extract that only 3 countries produce the metal: the US, China, and Kazakhstan, and it's mostly the US. But hey, beryllium is what gives emeralds their green tint. Boron is kinda boring. It's basically just beryllium 2.0, but it's even more toxic, and it's even more expensive. It doesn't even really have any interesting uses. Like, beryllium is used by NASA and aerospace engineering and all this cool stuff, but boron is used to, treat yeast infections. And that's about it. Unlike most elements, almost all the boron in our universe was made in supernova explosions, due to its fusion product being very reactive. Yeah, boron is so unpopular that even its most common isotope would rather be something else. It's the main ingredient in borax, the household detergent you can use to make kid slime. So that's fun. You can also use it to make cubic boron nitride, which under the right conditions can actually be harder than diamond, which I didn't even know was possible. But it's so much rarer and pricier than diamond that I couldn't even find a single place to buy it online or even know what the industrial price is, so we likely won't be seeing boron rings anytime soon.
There's graphite and diamond and charcoal and carbon monoxide, and coke. Carbon-14 and carbon fiber, buckyballs, fullerene, skrillex, and smoke. Anthracite, bitumen, piton, lignite, petroleum, methane, and steel. Graphene and carbides and ethanol, plastics, epoxy, propylene, and zeal. There's carbon black, rubber, carbonate, asphalt, called biomass, green trees, and tar. Nanosys, polymers, carbonyls, allotropes, organic compounds, and spar. There's carbonate, cyanides, carbides, hydroxide, and tungsten and fillers for air. Ester chains, acetone, organic pathways, and carbon steel everywhere. There's isotopes, carborines, carbon electrodes, diamondoids, those shining so bright. Activated carbon, graphitic materials, carbon nanocosylite. Carbon composites and aerogels, filters, covalent bonds holding them firm. Methanol, ethanol, carbocation ions, and fossil fuels we confirm.
Nitrogen is the 7th element on the periodic table and, believe it or not, by far the most common element in our atmosphere, making up over 70% of the stuff we breathe. It's got 5 electrons in its valence shell, which allows it to form super strong triple bonds like cyanide and N2, which is the stuff in our atmosphere. In fact, these bonds are so strong that plants can only get nitrogen in the form of ammonia, which has much weaker single hydrogen bonds, and the only way ammonia forms in nature is through lightning strikes vaporizing into in the atmosphere, which you can imagine isn't very common. Luckily, there is a kind of bacteria that somehow figured out how to do it with an enzyme, but this enzyme is so ridiculously complicated and not even really that efficient that we instead use the Haber-Bosch process to manufacture ammonia on an industrial scale. It's basically nuclear fusion, but with ammonia. This process alone is so terrible that it uses up over 1% of the entire world's energy. But without it, we wouldn't have food, so there's a Nobel Prize waiting for anyone that can discover a more efficient process. Oh, and it can also be used to cool superconductors. Oxygen is, you know, the stuff that we breathe, and without it we would all die, so it's pretty important. Interesting enough, it's the 3rd most common element. I expected the pattern to continue after hydrogen and helium, with lithium being the 3rd most common, but instead it skips like 5 of them before jumping back to carbon and being quirky. It's easily the most common element in the Earth's crust at over 40%, and can I just say, my god, is this a beautiful infographic. Thank you, elements.visualcapitalist.com. I just wish it was 16 by 9. The reason oxygen is so common is because it really likes to form compounds. I mean, you give it an iron oxide. You give it a carbon, and bam, carbon monoxide. Don't breathe that. Nothing is safe from oxygen. Not even itself. Oxygen is more basic than a pumpkin spice latte because of its unique configuration, allowing it to join up with 2 hydrogens because of the 6 electrons in its valence shell that want to be 8 because neon is cooler. Liquid oxygen is also magnetic, which is pretty weird to think about and gives me existential dread. Fluorine is the 9th element on the periodic table and our first halogen. Unless you count hydrogen, but most people don't know where to put that, so I'm just going to give this one to fluorine. Halogens are the far right group on the periodic table and easily the most reactive because they're only 1 electron away from being in a stable configuration like the noble gases. Fluorine is so reactive that it's often used in glass etching, and it's a main ingredient in hydrofluoric acid, which is the stuff they used in Breaking Bad, which makes it really good for your teeth. This is because it replaces the hydroxyl ion or something. I don't know, I'm not a dentist, but it's very important. Fluorine is also used to make CFCs, which, if you don't remember, the stuff that almost burned a hole through our ozone layer and will still be recovering from it until 2066. And it's used in Teflon, which is very toxic and has led to a lot of accidental death and cancer. I can see why people are afraid of it. But no matter what the brainworm man says, it's very safe and does not, in fact.
Turn the friggin' frogs gay! Do you understand that? Turn the friggin' frogs gay! Serious crap gay! Frogs friggin'...
Neon is the 2nd noble gas, and it's primarily used for, well, you know. Although, modern signs typically use LEDs to mimic the effect of neon, because it's very expensive and hard to work with, plus LED signs look much cleaner anyways. All noble gases actually emit light when an electric current is passed through them. However, neon emits a very bright, striking red glow when ionized, compared to, say, argon, which emits a gross, weird-looking purple. Other than neon signs and old-school plasma screens, neon basically has all the same uses as helium. You can cool it down for superconductors, or combine it with helium to make an extremely powerful, scientifically pulsating laser. And that's about it. You'd think neon would be more interesting, but nah, it's really just helium's older brother. Video's over, you can leave. Sodium is the 11th element and the leading cause of preventable death worldwide, killing more than every single infectious disease combined. Salt is actually pretty good for you and a rather important mineral for bodily function. However, Americans eat... My god, is that a lot? How are there not more deaths? This is insane. The reason it's such a problem is because in its consumable form, sodium chloride or table salt, it's very water soluble, meaning it attracts water into your bloodstream, increasing blood pressure, which can cause strokes and heart attacks and all that good stuff. But hey, it tastes pretty good. Magnesium has a lot of similar properties to our friend Beryllium. It's a lightweight, squishy, reactive, and toxic metal. This is because they both sit in the same group as alkaline earth metals, with 2 electrons occupying their valence shell, which gives them their unique properties. Unrelated tangent, but while I was researching magnesium, I came across this article that says magnesium makes up over 13% of Earth's total mass, and I thought, huh, that's cool. But then it claims that that's the same as Mars, and that makes absolutely no sense. But I looked it up, and yeah, Mars weighs 10 times less than Earth. I'm so used to thinking they're basically the same, but Mars is actually tiny compared to our planet. Anyways, where was I? Oh yeah, magnesium is super important for bodily functions because it's a key component in a lot of enzymes our cell uses to carry out reactions. The main one being this guy, hexokinase, which is the enzyme responsible for the phosphorylation of glucose during glycolysis. If you have no idea what any of those words mean, don't worry, because neither do I. All you need to know is it's important. Aluminum is the type of can I'm drinking out of while making this video. Believe it or not, but aluminum cans are actually lined with plastic, because if they weren't, your soda would taste all aluminum-y. You can't escape microplastics. Aluminum is the cheapest metal, not counting steel of course, or lead, but I don't know why you would need to buy lead unless you want to poison a child. Aluminum used to actually be more expensive than gold, just like 2 centuries ago, because it was extremely difficult to refine since it required high heat. It was actually so valuable that during the construction of the Washington Monument, they put a 100-ounce aluminum cap on it that cost $225, or around $7,000 adjusted. That same amount of aluminum would cost like $7 now. They definitely did not get their money's worth. Of course, nowadays aluminum is so cheap to produce that we use it for disposable diabetes cans or
the aluminum foil. Never settle for less.
Silicon is the 14th element on the periodic table, and if you notice, it's got the same Goldilocks number of electrons that carbon has. For this reason, some speculate that silicon-based life would be possible, since it can form the same complex structures that carbon can. It also helps that silicon is significantly more abundant on our planet than carbon, and there's no reason to think it would be different on others. While carbon-based life breathes in carbon dioxide, taking the carbon in for growth and releasing the oxygen, you'd expect silicon-based life to do the same thing, breathing silicon dioxide. Silicon dioxide is sand, so be thankful that you're carbon-based. Silicon, like boron, is a metalloid, meaning it exhibits properties of both metals and non-metals. Silicon is also a semiconductor, meaning it's somewhere between a conductor and a resistor, making it super useful for transistors, which is why it's used in computers. While there are other semiconductors, silicon is dirt cheap, and who doesn't love a dirt cheap transistor? Phosphorus is the second most common mineral in your body after calcium. Serving as the backbone of DNA, it also strengthens your bones and teeth, keeps your membranes in your cells, helps your nervous system function, delivers oxygen through your body, a whole bunch of other things that would probably take me like an hour to list, but yeah, it's pretty important. White phosphorus is incredibly reactive and used in warfare, especially in one specific Middle Eastern war going on right now that I will not name in fear of being striked. Unlike its brother, red phosphorus is actually pretty chill, just don't mix it with water. Phosphorus comes in all different kinds of flavors, so make sure you try them all. Just don't make phosphoric acid, I hear it's bad for your skin. Phosphorus also glows in the dark. Ooh! Phosphorus was discovered in 1669 when Henning Brandt cooked some urine in a pot. Don't ask me why. Sulfur is the 16th element and is abbreviated as S, not Si, as I learned the hard way. You've probably heard that sulfur smells really bad, but it's actually pretty chill by itself. However, it's fairly reactive, and if given the chance, it will form hydrogen sulfide, the chemical that gives it its nasty, characteristically rotten egg smell. Sulfur is also a common characteristic of... hell. But it's not all bad. There are some cool things about it too. When you light it on fire, it glows blue. On second thought, that might make it even scarier. Moving on. Sulfuric acid is the stuff in car batteries and your stomach. Can we be done with this element? I don't like this one. It's horrible in every way. It seems like there's nothing good about it. Chlorine is probably one of the scariest elements, and you guessed it, it's the second halogen, after fluorine. And just like fluorine, it has a ton of mundane and inconspicuous uses, like how we dump a ton of it into swimming pools. But it's actually pretty chill, because it kills all the bacteria and viruses and gross stuff living in there. It's also one of the main ingredients used to make mustard gas, used in chemical warfare that killed tens of thousands of people and led to long-term health complications like respiratory issues and cancer. And it's one of the main ingredients in table salt. It's also what makes up CFCs, which are the stuff we used to put in literally everything, and burnt a massive hole in our ozone layer, which I blamed on fluorine, but it's really more of a team effort. It's got one of the least creative names. Chlorine as a liquid is yellow-green, so guess what they named it? Yellow-green. I could honestly make an entire video on dumb chemical names. Argon is pretty cool. The only thing I know about argon is that it's the element that I always forget is the third most common in our atmosphere. It's even above CO2, weirdly enough, by a factor of almost 30. Interestingly, the reason it's so common is due to potassium-argon decay, which happens so often that we use it all the time to date rocks, and the leftover argon products just kinda stick around in the atmosphere. Argon is a noble gas, which means it kinda just wants to be left alone and doesn't react with anything. Due to its abundance on Earth, this makes it extremely useful for all sorts of applications like welding, light bulbs, document and artifact preservation. Basically, if you want anything to not react with anything, argon is your guy. It also makes a purpley bluish glow when you pass an electric current through it, and it's the stuff inside those weird looking plasma ball thingies. Are you gone yet? Alright, I'll stop.
Ba 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 na na. Ba 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 ba.
Okay, well, that's enough of that. If you didn't know, potassium is a very common mineral in bananas. However, you'd still need to eat like 11 a day to get your daily recommended intake. If you watched my video on argon, which you should, you'd also know that potassium loves to decay into this stuff, which is why there's so much argon in the atmosphere. This means that bananas are radioactive. They're not that reactive. You need to eat like 10 million of them in one sitting to die of radiation poisoning, which I think you'd die of other things first. But they're reactive enough that real scientists with real PhDs working in real labs, often using your real tax dollars, use the unit BED or banana equivalent dose when talking about radiation. You can't make this stuff up. It also makes a purpley flame when lit on fire, and other than that, it's basically just sodium on steroids. It's a light, squishy metal that's super reactive and an important electrolyte, blah blah blah.
I see you got the extra whipped cream in there, huh?
Yeah.
Yummers.
More like calci-yummers. But seriously, kids, calcium is a very important mineral for bodily function, and calcium deficiency can lead to muscle cramps, bone loss, and even chronic medical conditions like osteoporosis. But what makes calcium so important? Well, if you've taken anatomy, you'll know that not only is it the stuff that solidifies and strengthens your bones, it's also the main electrolyte driving the muscle contractions in the sarcolemma. But don't have too much of it, because it causes kidney stones, which you don't want. Unless you're a masochist. Fun fact, it's the stuff that makes up limestone, which is the same stuff that makes up chalk, which is the same stuff that makes up Tums, like the antacid. The more you know. I personally hate drinking milk. If you don't like milk, cheese has a lot of calcium too. If you don't like cheese, there's seriously something wrong with you. Go see a doctor. These last 5 seconds are just to pad the runtime a little because I thought it'd be cool if it said 2025 in the timestamp.